Hello and welcome, everyone. My name is Pontus, and I work as a security researcher, and I like to hack things.
And my name is Tobias, and I like to build secure applications. We both work at Omega Point Gothenburg, and we do penetration tests and security reviews. So together we have a lot of experience both building and attacking implementations with OAuth and OpenID Connect.
And today we will show a few things that can go bad in OAuth2-based implementations, even if you've done your best to follow the best practices and security recommendations. And before we get any further, I want to point out that if you're not currently following security recommendations and best practices, you might have a lot worse problems than the ones we'll talk about here. So going forward, we simply assume that you've done your homework as developers and architects and invested in a solid solution and have a good understanding of high security OAuth and OpenID Connect.
Yeah. So the focus for this presentation, you need to
sorry.
do like that. So these are the topics for today, and the focus for this presentation will be on security challenges and how to address them in the context of the backend for frontend pattern for OAuth. This is well documented in OAuth best current practices for browser-based applications, which is a really good RFC document to read if you like. We'll do demos. The first one will be with Duende Identity Server, but there are of course many other good products that you can use that fit your business requirements and so on, like Auth0, Security, Azure AD, and so on. And another good, well-known token service is Keycloak, which we will use for the last demo. And here, Pontus, during a pen test in December, found an issue concerning dynamic redirect URIs, which we will show later. But we want to point out that this talk is not about specific products or framework. So it's about general OAuth design challenges that you need to address, valid for most implementations with OpenID Connect and OAuth.
Yeah. So are there anyone in the room running Keycloak? Some hands? Good.
Good.
So the last demo will be a vulnerability in Keycloak that has been patched. So this is a part of a coordinated responsible disclosure. We've worked closely with Keycloak, and they are fine with us disclosing it here today, but it is the first time that I'm speaking about it, so this is news. Yeah.
So with this sort of cliffhanger, we will go back to the backend for frontend pattern, and to set the context for the first demo, we will sort of try to mentally travel back in time to about 2019, and look what can that be like.
Yeah, so remember 2019, before the pandemic, apparently it was the best year ever. Unfortunately, it was not the best year ever for OAuth2 best practices.
So who hasn't updated their OAuth and OpenID Connect design and implementation since then, right? And so this is what a typical 2019 implementation looks like. And just to point out that the things that we talk about, it concerns both OpenID Connect and OAuth. And in this presentation, we mostly say best current practices for OAuth. And that the context here is that we have a system with the high security requirements, like in healthcare and finance. So we need to keep a good level of security. So we have a token service up to the right there. And then we have a set of APIs. And in reality, this could, of course, be 10 or hundreds of API hosts. And in this demo, we will have 2, just to represent that there is more than one. And the access model for our system here is that the logged in user should be able to get products and the user's orders, not other users' orders. So that's important to keep in mind. And the user should not be able to get all orders, of course, reaching the get all orders endpoint. That endpoint is meant for an internal system integration, and that's the order processor there. So this access model is good to keep in mind when we do the demos. And then we have the single page application. It's a standalone SPA. So that means that everything happens in the browser in JavaScript. According to the 2019 best current practice, we do openly connect code in the browser there. And we also use something called silent renew. That's you're likely to use that in order to refresh the short-lived access tokens during the user session. And it's also common that we store those tokens in local or session storage. And then the code flow, which you might be familiar with, is just represented with one arrow in this, and that's the token request. But in reality, there are, of course, a lot of arrows going back and forth. But it's important here to just understand that the token request goes from the browser front end to the token service. So the goal here for the attacker is to try and misuse this and get more data than it should be able to. So let's see, Pontus. Let's see if you can steal tokens and misuse this in some way.
Yes. So
time for demo.
Yeah, let's switch over to the demo. So I have my browser here, and to the right I have Burp Suite, which allows us to inspect the network traffic as we go along. So I'll first load our single page application. There we go. And to do anything, I first need to log in. By hitting that button, I'm redirected to the IDP, in this case, doing the identity server. And as I log in, a lot of things happen. So the first thing that happens is that after entering my credentials, I'm redirected back to the single page application with an authorization code. And that code is then sent back to the IDP in exchange for an ID token, an access token, and a refresh token.
Yeah, so that's token request.
Yeah.
That was in the picture.
And after that, I can access the functionality of the application, retrieve my orders. I can do some product search. And if we look at those API calls, we can see that the access token is attached as a bearer token in the authorization header. So far, so good. One way of stealing tokens is a good way to do that is if the application is vulnerable to cross-site scripting, which is still a very common vulnerability, especially in a bit older applications. And good news for us is that this application is super vulnerable through the search field here. It accepts and renders any HTML, so it's a fantastic vector for us. And even though in this scenario, the access token is just stored in local storage, so we could just get it from there and send it to an attacker server and use it like that. We'll instead go for the silent renew flow. And the way that works is when the token is about to expire, the application creates a hidden iframe in which it loads a page on the IDP. And then the single sign-on cookie is automatically attached to that request, and it gets a new code, and it exchanges that code for a new access token. And if you've been paying attention to the request log, you've seen that it's moved while I've been talking, and that's because we have very short-lived access tokens in this case. So to demonstrate that, I have set up an attacker server that is set up to receive the authorization code and then exchange that for an access token. It also hosts some JavaScript, which I will, through the XSS vulnerability, load in and execute. And what it does is create a silent renew iframe to steal the authorization code. So I'll just copy the payload here, and now pay attention to this middle box here. So we got a code, and we exchanged that for an access token. So now the attacker has an access token and can use that to impersonate the victim user and perform arbitrary API calls.
Yeah, so not good. And we should note that Pontus didn't steal the actual token. He steals the code and act as the client, just as it's designed to do, and silently renewing tokens. Also, we use the fact that we can run code in the same origin as the application with a valid session cookie to the token service. And there is a public client, so it has no client secret because JavaScript can't keep secret, so we can't use that. And yeah, so that's why we shouldn't do this in the front end anymore. And yeah, we have gone back to the slides, and this is what we saw here. He had the attacker server, and we are the wrong window. What?
The wrong window, not on my machine.
No, that's strange. I know, but there, yeah. Okay. So if you think about the picture you just saw, we had the attacker server, and we had the cross-site scripting vulnerability, and now we see it. So that was what we showed in the demo. And unfortunately, cross-site scripting has been around for many years, and it's still common to find, of course, and especially maybe in older SPAs and older frameworks from 2019 or so. So if the attacker can run in your execution context within your origin, the attacker can do anything your application can do, like renewing tokens. Maybe you could have some sort of defense in-depth techniques, like a solid cross CSP in place, content security policy. But unfortunately, that is often not the case for most applications because they are hard to get right. So there are many ways for Pontus here to steal tokens using cross-site scripting. And if you want to look more into this, we can really recommend Philippe Deric's presentation from NDC Security last year. It was really good on this topic. Yeah, so what do we do to fix this? And the answer is obvious. We move forward and follow the best current practices of today. And then we take a look at that, how we will. And here we have refactored the SPA. To follow the current best practices, and this means that we use a backend for front-end pattern. And the SPA here is almost exactly the same. The big difference here is that we have moved all openly connect OAuth stuff that happens in the backend now. So this means that we now have a confidential OAuth client, and that we have no tokens in the front end anymore. So instead, we need to protect the session to the backend for frontend with a secure cookie session, and that really is secure. We have done that properly with cross-site request forwarder protection and so on that Philippe talked about before lunch. So no issues there. And also, since we now have a confidential client with a that can keep a secret, then we can use more security features like strong client authentication with mutual TLS or DPoP, and then we can also use sender constrained access tokens following the best current practice or the best practices from Openly Connect security profile FAPI for financial grade, it's called, but that also applies to any system with high security requirements, like within healthcare and so on. And that's also a good read. So there are no tokens to steal, and as you can see, we also have added a gateway, a firewall, a properly configured web application firewall. That's so now the get all orders endpoint, it's not even exposed to the internet anymore. And the only thing that's exposed to the internet actually is the backend for frontend. So now, Pontus, try and steal all orders if you can.
Yes.
I dare you. I double dare you.
Let's go back to the demo and verb. Let me just clear the history here and log out, and I'll load up the next SPA. So again, to do anything, we first need to sign in. We use Duendo again. If we look at the network request, now that with this new setup, we still have the auth request and the authorization code going through the browser, but we have no token request because that happens between the backend for frontend and the token service. And if I do any of the API calls, we see that there is in fact no authorization header and no token in the request. What we do have instead is this session cookie from the backend for frontend. And that cookie is secure, only transmitted over HTTPS. It's also marked with HTTP only, which means that it can't be accessed from JavaScript. So even though this application is still vulnerable to cross-site scripting, we cannot access that cookie and steal it and exfiltrate it to our attacker server.
You can also notice the host prefix on the cookie there. It also enables security features in the browser.
Exactly, but I mean, we still use silent renew to renew our session. We can try the same exploit as before. So we'll try that. Paste it here, and sure enough, we're able to steal a code. However, when we try to exchange that for an access token, we get an error from the token service. The error is pretty nondescript. It says invalid client. But if we look in the window above here, which is the logs from identity server, we see that it says client secret validation failed. Because our attacker server does not have the client secret for this client because, well, it's secret. So we can't use that to steal tokens anymore. Should, however, note that since we have a cross-site scripting vulnerability, we're still vulnerable to something called session writing. So any JavaScript running on this site can still access the APIs using the cookie. We just can't exfiltrate that cookie. That means that our window of attack is much smaller. As soon as the victim user navigates to another page or closes a tab, that attack window closes. But it's still vulnerable, and you should fix your cross-site scripting vulnerabilities anyway.
Yeah, so that's all good.
Yeah,
it's good with confidential clients there, as you can see. But we also have this third endpoint, the get all orders endpoint. And as Pontus just has said, we have limits if the attacker is running code within our application. We have limited to just to proxy requests and misuse the user's session. So, and the user, it doesn't have access to the get all orders endpoint. So that's sort of fine. So now the goal here for the attacker is to try and break out of the user's session. And so let's see if you can do that with all those defenses in place that we have.
Yes. So we have the get my orders endpoint here, and when performing penetration tests, you shouldn't. I mean, you don't really trust the documentation. You test other things. You might fuss some endpoints. If you are aware that there is an endpoint that a separate endpoint that should not be public, that returns all orders. You might try something like adding /all here, and we get all orders.
Not good. so even if we, I mean, how does that happen? We had invested like a month in security here, refactoring, adding firewalls and all that things, and just by changing that route, we can access the get all orders API. It shouldn't be possible. So to analyze this, we have gone back here to the drawing board, and so the problem here, it seems to be some expected issue concerning the routing, right? So let's start by looking there. So this is sort of a default proxy configuration. So what's the issue with this one?
Yeah, so Dominic Beyer talked yesterday about stars and wildcards in another topic, but sort of applies here as well. Can you see the stars in the match path statements here? What they do is basically that any requests to the /order/API endpoint get proxied to the backend order API, regardless of whether it's what comes after the final slash there.
Yeah, so this is of course great for the sort of developer experience and availability. Everything just works out of the box without doing any configuration, but it's really bad for confidentiality and integrity. It's in a larger system, it's hard to keep track of exactly which endpoints you can hit from this backend for frontend, which act as a proxy from the internet. And so let's look at the system overview once more. And so if we look at the backend for front end here, its job is of course to proxy requests, and it's quite common for you can see we have 2 hosts here, and but it's quite common that you mix within the same host or the microservice. You have endpoints meant for login users, and you have endpoints meant for system integrations. So even if I think all proxies, they require that you specify an allow list for which hosts you can route to, but that may not provide any protection, because the backend for frontend here, it will need to access the order hosts, because it needs to reach one endpoint there. So that means that in a worst case scenario, the backend for frontend will be a proxy to all internal APIs anyway. But I mean, they are APIs. They should be. In 2019, they were exposed to the public internet. So why is that so bad that we can end up in the get all orders endpoint?
Yeah. So and that's because the backend for frontend has 2 responsibilities. It's a reverse proxy routes requests, but it also attaches the user's access token to the requests.
Yeah. Yeah, but then again, I mean, it is an access token connected to the user's session, giving access for what the user should have access to. So why is that so bad that you get an access token with the request to the wrong endpoint? That shouldn't be a problem if your API does proper access control. But the question is, does your average API do proper access control?
No. At least in my experience, pretty much any system of a given complexity has some issues with access control or authentication. And if we look at the OWASP top 10 for API security, we can see that 4 of the 5 top points all relate to authentication or authorization. So it's a very common problem and something that's quite hard to get right in each and every place.
Yeah, so what makes it hard in this case is that often the backend for frontend, it needs to get user data from maybe most of those microservices. So there will be a lot of scopes and a lot of audiences in this token. So it's hard for the ones building the APIs to do proper access control with such a powerful token. And so we will go into more on that later, why that is hard to avoid and how we can address that. But besides API access control, there are other things to consider as well. For us, the successful attack that we showed there are actually 4 issues that needs to be present at the same time in order to succeed. And we'll take a look at that.
Yeah, so first up, as an attacker, we need to have a low privileged session to the system. That can be super easy for some systems because there's some systems allow you to just register an account. But in other cases, there are many good ways of stealing credentials. Phishing is a big problem for many organizations, and as the old saying goes, hackers don't break in, they log in. Many backend for front-end clients that we see have access to call all the API hosts on internal networks. It's very uncommon, I believe, for people to remember to do the old boring network segmentation and IP plans in the cloud. We often see BFFs with this catch-all routing with wildcards that just forwards any requests to the underlying API hosts. And finally, authorization bugs. We find those in practically every system that we test. Yeah, so at first it might seem likely that all those 4 things are present at the same time, but if we look at them like this, it's really not that unlikely, and it's definitely a risk worth considering. So before we look at how we can lower the risk of this kind of vulnerability, we want to point out once more that if you do not follow the best current practices, you could have worse issues to address than the things that we talk about. So how should we address this? Well, as always,
This sort of sound security principles will guide us in the right way. Zero trust, least privilege, and defense in depth. We should build strong solutions with defenses in multiple layers, and we should not trust that the gateway does access control for us. The API needs to be able to do proper access control on its own. But to talk about all this is a talk of its own, and we will just focus on two things here in this presentation. That's to implement proper API access control and the routing, that the BFF should only route valid requests and not to the system integration endpoint. So let's take a look at that and how we can fix that.
Yeah, so the solution is quite simple. It's using a strict allow list where you specify the exact method and path for each endpoint that you should be able to reach. That gets super simple when you only have a system with two endpoints. It might be a little bit harder when you have hundreds of endpoints or more complicated. But using being lazy and reverting back to wildcards will sooner or later bite you in the ass.
So don't try to be clever there.
Oh.
It's really hard. Yeah. So with this change, then we get the overview like this.
Yeah. So now only the exact methods and paths that we expect are able to route through the backend for frontend and through the gateway. The get all orders endpoint is actually no longer accessible from the internet. So with this change in the routing configuration, we have successfully mitigated the vulnerability. However, there is still the issue of improper access control. We haven't solved that. If we would have solved that, it wouldn't matter as much if the get all orders endpoint was public. But it can be hard to address the access control issues. And next up, we'll look at the scope challenges the backend for frontend pattern might introduce.
Yep. But before we take a look at the scope challenges, we take a look at the initial auth request with the code flow. That will always go through the browser, even if we do the backend for frontend thing. And this means that by design, the user or the attacker can change all of these parameters that we see here. So all the scopes that a client has been configured to be able to use is the user or attacker able to add to this request. And why can that be so bad?
Well, it's quite easy to misconfigure scopes, to add them by mistake, or just add all available scopes to make things work, and you create a ticket, remove all scopes before going live, and so on. It's also quite easy to reuse clients for multiple applications or roles.
Yeah, so it's likely that an attacker can add more scopes to the access token than the client actually needs. And in example, if you combine a client which is used for a user to log in with the code flow with client credentials, sort of use the same client for both scenarios, then that means that the user that logins will have access to the same scopes as the internal system integration has. And then if you have APIs that make authorization decisions based on just a valid token and scopes, then you might have a problem there.
But I mean, yeah, that's scopes, but we have a lot of other interesting parameters that we can modify as malicious users or attackers. And let's have a look at another demo.
Yep.
So I'll load up this example. In this demo, this is not the vulnerability demo, even though we're using Keycloak here. So here we have, now we're using the Keycloak IDP instead, so we can log in, and that's fine. So it works. If we log out and log back again, here we have the authorization request, and here we have all those parameters that we showed on the slide. We have the client ID, we have a redirect URI, we have the response type code here that we want to use the code flow.
So we still have a backend for front end with no tokens in the front end, secure cookie and all that. But let's see if we can steal a token anyway.
Yeah, because what happens if I change the response type to token and log in? Well, we got an error. And that's because we didn't get an authorization code, which the application expects. But we did get a lot of things here in the URL fragment. We got a state, we got a session state, we got an issuer, and
it's really exciting now.
Yeah, and we got an access token. So in this case, the client was misconfigured to allow both the code flow and the implicit flow.
Maybe because you, in 2019, ran the implicit flow, which you shouldn't be using anymore, and you have refactored, but you forgot to clean up your client configuration, so you still have the implicit flow enabled for this client.
Could be.
Yeah, but there are also more parameters for us to change and modify, like the redirect URI. So what could go wrong if we try and change that?
Yes, so about redirects, this is what the OAuth specification says about them. Redirect URIs must be configured beforehand as part of the client configuration. And the token service must verify that the supplied redirect URI in the authorization request actually matches one of the configured URIs. And when doing so, you should use something called simple string comparison, which is a fancy way of saying you should compare them character by character. And it also specifies that the redirect URI must be an absolute URI. So looking at Keycloak, it comes with a couple of default openly connected clients. For example, the security admin console client, which is used to access the admin UI. Now, I understand if it's a little bit small for you to see, but the redirect URI configuration that's highlighted, it says that the following URI is allowed, /admin/master/console/star. So Keycloak supports wildcards as part of the redirect URI.
As an extra feature.
Yes. So this deviates from the specification and best practices. So we know we're out on thin ice here. But what can go wrong here? We do at least have a prefix that must match. And we also have the root URL. So if this is running on example.com, the redirect URL must be https://admin/master/console/something.
So we should end up at the same host anyway. That's the idea. Yep.
Exactly. But it turns out that using multiple tricks, such as double URL encoding, HTML entity encoding, HTTP basic auth URL formatting, as well as fiddling a bit with the response mode parameter, we're able to construct this fun redirect URI, which passes the redirect URI validation. But instead of sending the authorization code or access token to the Keycloak instance, it sends it to example.com. So this is an open redirect vulnerability in Keycloak that we reported in December.
It's simply a bug with the star function. It wasn't meant to work this way. Right?
Exactly. No. And this affects all Keycloak OAuth clients using redirect URIs containing wildcards. It's been patched in Keycloak 23.04, which was released earlier this week. So this is quite new, so you should go home and update your Keycloak instances if you haven't done it already. So we've worked closely with Keycloak throughout the reporting process, and they've acted really quickly, developing and deploying or releasing the patch, and they have signed off on us disclosing it here today. I won't go through all of the details how we ended up with this URL. If you want the technical details, you can go and read them on the on our blog, where we have a link here. But with that, I think it's time for us to do a demo of it. So let's see here. Here we have the Keycloak admin console. And here we have the authorized URI again. But we don't want to use the standard authorized URI. We want to use my special authorized URI. In this scenario, we will not send the code to example.com. We'll instead send it to Burp Collaborator so we can see it instead. So paste it here. And so when I sign in here, I expect to receive the authorization code in the right window. We do poll. We got some requests. That was the get. Here we have the post. It gets sent as a JWT, but if we decode that, we can find the code. And I copy the code, and this is a public client. So I can just create a token request, paste the code, send it, and get the access token.
Yeah, so we should note that this is a good example of the importance of being secure by design and limit attack vectors and avoid extra features, perhaps. And because it's hard for the development team building this wildcard functionality to understand how it can be misused and identify a test case like this, like the one Pontus discovered. And this is important to understand both as developers of the auth server, but also for us using this service and configuring it, because even if you can enable this dynamic redirect URI, you shouldn't, because then you step away from the best current practices by adding the star there. So even if you don't have the possibility to patch, then maybe you can remove the stars, and that would also sort of solve the problem for you. So it's important to stay on the safe side and stick to the best current practices. And in OpenConnect FAPI, it would look something like this. And as you can see in the second line here, let's mention the shall use pushed authorization requests. And that was Dominic Beyer talked about PAR in depth yesterday, and you can read more about that online. We won't explain more here, but the auth request looks, then if we use PAR, then it will look like this.
Yeah, and then we just have the request URI, which references all the parameters in the original auth request. So there's pretty much no parameters for an attacker or malicious user to modify.
So back to scope issues, and we have. To sort of summarize that, we have this sort of defenses and insights here, and we should of course assert least privilege for configuration for both for the client there, and we shouldn't mix code and client credentials for the same client, or support implicit anymore. So keep that clean, and do not base sensitive operations authorization for those on just a valid token and scopes. Use something more like perhaps client ID or authentication method and so on. And follow the best current practice, and don't use those wildcards configuration either in the routing or in the redirect URIs. Now to another scope issue, and why it's so easy to end up with kind of global access token in this backend for front-end scenario. We're having an architecture that looks like this. We have the backend front-end and a set of APIs, and it could be a lot of APIs there. And then we get an access token, token A, and that needs to be valid for all APIs. So we will have all scopes and all audiences in that token. And it could also look like this. And there is a chain, and that could be, of course, many hops there. And that is a challenge for OAuth implementations to handle that. But so that this can become quite large in a large organization. And it's not that uncommon that the token becomes so large it doesn't fit in the HTTP header anymore. And if you run into that and you solve that by increasing the header size, then you sort of know that you're on the wrong path in your scope design and maybe need to rethink it and deal with it in a better way. So what can we do to sort of have least privilege in our access token so we don't have this global access token? A common pattern is to do like this. You get the token A there, but that's only valid for API 1. And then API 1 will use client credentials and get a token for API 2 and then another token for API 3. And then we have solved the sort of scope issue here because we have least privilege. We have just the scopes and audiences we need for each request here. So that is good, but we lose another thing here, and that's if the traceability and accountability, because the user log in the back and front and get a token, and the new tokens here, they are not really maybe attached to the user session anymore. So if that's important for us, then we need to do something better. And that is a token exchange, and also known as on behalf of. And so it works almost the same. It's we get token A, and then we exchange token A for token B or token C. And if we look at how the token will end up, then we can see that the scoping is the same, but now we get this ACT claim in the token that can show this chain of the request chain, so we can verify that and keep the traceability and prove that the user initiated this operation or request. So please consider token exchange if this is important for you. And we should also note that even if we do token exchange and things like this, we still have the session writing problem. That hasn't been solved. So that's always there.
If your BFF is vulnerable.
Yeah. If your BFF, yeah, of course.
So with that, we have shown how to build secure OAuth2 and OpenID Connect implementations following the best current practices, and how to avoid some of the common pitfalls and misconfigurations. We've also addressed the routing and scope issues, yep. And now it's time for us to summarize. So first of all, please read and follow the best current practices for OAuth2 and OpenID Connect, the OAuth2 1 and FOPI financial grade.
Those are good places to start, to finding RFCs and so on.
Yeah, and both those two documents are actually quite easy to read and digest and understand. So it's they're much easier to understand than the original core OAuth2 specification. Also, stop handling access tokens in JavaScript frontends. Instead, opt for using a backend for frontend with a strict allow list, so to not let your BFF be a vector for authenticated server-side request forgery. Yeah, and as always, make sure to do proper access control in the APIs. Do not trust gateways and other things will do that for you. So assert that you follow the principle of least privilege, but also use defense in depth. Yeah, and as always, don't be vulnerable to cross-site scripting. Employ proper output encoding and perhaps add a strict CSP. Then that's it for us. If you want to know more about AppSec topics, we have written quite a couple of articles that are published on our security blog. You can also find the write-up for the Keycloak vulnerability on there. There's also links to some other talks by me and Tobias and some other colleagues. Yeah. Thank you.
So, thank you.
Any questions?
Yeah. Yeah, so the question was about the mobile clients and how they should handle the OpenRE Connect or OAuth. And there the recommendation is to do the code flow, but to do it in the mobile app. This means that the mobile app will be a public client using the code Pixie flow. So that's not good because we will have tokens on a device that we don't control. But the mobile device is our application is more separated from other because it doesn't run in the browser in the same way as a standalone JavaScript SPA. But yeah, so it's not perfect, but it's that's the way it is using the system browser for the logging.
Other questions? Yeah.
Yeah. Yeah.
Yeah. It was mostly to symbolize that the BFF is, of course, publicly exposed to the internet while the underlying APIs are not. So it was...
Yeah.
Yep.
Yes. So the question was about we had in the system overview, you can show that perhaps we had the gateway behind the backend front end there. Yep. And that was just to show that you have a network segment where you aren't exposed to the internet. The backend front end is, but there could of course be more infrastructure protection in here that we haven't showed. So the backend front end should have something in front of it providing DDoS protection and things like that. But that's but it's also quite a common setup that you might have an application exposed to the internet like that. But it would simply be a reverse proxy. Yeah. And yeah. Yes.
Would you recommend for multi-tenant single-page application using that can be multiple logged-in user at a time? The cookie can be only a single one. What kind of action would you recommend?
Was the question if this backend for front-end pattern is suitable for multi-user system, multi-tenant systems? Oh, definitely. This is just plain old cookie sessions, and that's yeah. That is if you have a very large system which needs to scale, and you have sort of the load test that shows that you can't use things like you will need a distributed session cache here and or have sticky sessions for this to work when you scale out. So then maybe you have to look into other features where you have the state client side. Then, but so that depends on the performance. But I would say in our experience, both building and reviewing systems, back and front end, in example in Azure, where you can scale out, is perfectly suited for most systems that we have come across. But it's so I don't know if that was, or what are your concerns?
Yeah. So there's a two-page application and running in the same host, and want to handle multiple sessions at a time, but key is a global thing for a host.
No. Each browser instance or user will have its own cookie. Yeah.
I know that on multiple browser, different machines, but inside. So, like say, if I want to check multiple projects, multiple things using the same application. Like for instance, I might reveal some clues, but Gmail can have multiple accounts, right?
Yeah.
And you might be logged into several ones. How would you address that using OAuth2 or OIDC?
So so that's really not an OAuth issue. It's a session issue, but we can talk about sessions. So you're having an application where you want to be able to, the same user should be able to log in, use the same browser, and log in with different accounts at the same time. Is that your issue? Yeah. So maybe we could talk about it afterwards. I think it will be a long answer, but yeah.
Do you have any experience with the OAuth2 proxy? Get that instead of the identity service? It's open source project.
Sorry, what was the name of the?
OAuth2 proxy.
No.
Nope.
No, I haven't. But sounds interesting. We should look into that. Yeah. Thank you. So, any more questions? Yes.
Did you in fact verify the Keycloak remedy?
Yes.
Reacting quickly and patching is not always good.
No, it's not. So yes, we did verify that the Keycloak patch was solid, both by reviewing the source code and testing again, and it looks good. But good question.
Yeah. Okay.
Okay. Thank you very much.
Questions? Thank you.